Hello, welcome. Let's try to solve another Leetcode problem, 348, design tic-tac-toe. Let's first try to understand the problem. So we are given a tic-tac-toe class, and we have an init and move. So this init, we are just giving a value of n. So this means, this means the row and column of the matrix, it is both n. So this means the size of the board. So for example, if this is n equals to 3, so we have a board with the size of the board is 3. Yeah, and we are also giving a function move. So this move is that we are giving the position of row and column of the board, and this player can be 1 or 2. So if it is 0, 0, 1, so it means 1 would be here. Yeah, so the second 0 to 2, so 0 to 2, so this means 2 would be here. We just want to find if there's a valid condition. For example, this is 1, 1, 1 in diagonal position, so we're gonna return true. Or if there is a 2, 2, 2 at the anti-diagonal position, we're gonna return true. But there are also other positions like 1, 1, 1 in a row, or 1, 1, 1 in a column. Yeah, so basically we're gonna check all those combinations. Yeah, so there are two ways we can solve it. One way is we can use the on square to check the move function. Another is we can use on to check this move. Yeah, it means if no winners, we're gonna return 0. If player 1 wins, we're gonna return 1. If player 2 wins, we're gonna return 2. Yeah. So first, let's try to use the first method, because basically we're gonna use on square to finish this move function, and after that I'm gonna optimize this on square to on for each of the move operation. Yeah. So let's first try to define some variables. So I'm gonna define a board because this is gonna be the first way. Yeah. So this board would be 0 times so 0 array times n for r in range n. Yeah, so this is gonna be board. Now we are going to finish this move function. So I'm gonna write a check function. So inside of the check, I gotta give a player. Yeah, because it always depends on which player it is. So I will have a variable n, so this will be the size of the board. It's going to be the self.board. Or I can directly use the self.n should be equal to n. So from here, I'm going to use the n should equal to self.n. Yeah, so it should be okay. Yeah, now we are going to finish this player function. So for each of the turn, this player can be 1 or 2. So we have to check that. Yeah. So here inside gonna be a player. So if this player equals to 1, we're gonna do something else. If player is 2, we're gonna do something. Yeah. So if player 1 didn't return a 1 or player 2 didn't return 2, so we're gonna return a 0. So this is gonna be the check function. So after that, we're gonna call this check function. So we're gonna call this check. So inside it's gonna be a player. Yeah, and inside I also want to put the row and column inside. So I will put the row and column inside the check function. So here I'm gonna use one character R and C to represent this row and column. So from here I'm gonna use the row and column and player. Yeah. Now I just need to finish the logic from here. Yeah. But before that, I need to define some variables. Since I have the board, so I have this n, the size of the board, but I need to define some variables. So how to check row and column and diagonals? So I'm gonna use some dictionaries in Python. Dictionaries in Python can check. I'm gonna define some rows and columns. Yeah, but for this player, actually, I don't need to check the players equal to 1 or 2. I can check it from the outside. I mean, from here I can check if player equal to 1. Yeah, I can check from the outside, or I can check from the inside. I think it should be basically, yeah, the same, but basically it's gonna be ON square. But this is not the best way, but we can optimize later, or I can define some variables. Yeah, I can define some variables just to define it outside, or I'm gonna define it inside the functions. So this is the row and row. Yeah, so I will just use a check function. Inside I'm gonna check if a player equal to 1 or 2, but inside I'm gonna define some check dictionaries. So it's gonna be rows 1, columns 1. So it's gonna be the default dict. So inside it's gonna be integer, and similarly on columns 1, this is gonna be a default dict with the integer. Yeah, this is just used to check if it is valid or not. And I also need to prepare a diagonal. Yeah, so the diagonal would also be the default dict with an integer inside. Yeah, so here I'm gonna use for the dictionary, I'm gonna use 0 as the diagonal, and I'm gonna. Yeah, I think it doesn't matter. I'm gonna use maybe 0 as the diagonal and 1 as the anti-diagonal for the diagonal dictionary. Yeah, so this is gonna be the diagonal 1, and then I'm gonna copy it and make it to rows 2, columns 2, and diagonals 2. Yeah, now I think it's enough for me to check if it is okay or not. Yeah, because I want to make a ON square time complexity, so I need to loop through the board. Yeah, so for R in range n, yeah, because this is not ON, because I want to do an ON square from the beginning, because from the beginning maybe we think we can we can do an ON square for this move function, and this is gonna be 100 calls. Yeah, and there will be 100 I don't know how many move functions. Yeah, n squared calls, so it should be, normally it should be okay. N squared calls will be made to the move function. So if the n is 100, so this is 1 times 10 to the power of 4 calls, and for each of the move, it's gonna be ON square. Yeah, basically I think this gonna pass. Otherwise there will no follow up. We can do the ON time complexity directly. We don't need to do an ON square. Now we can check that. If the self.board with this R and C, because it always depended on the we have to check if the player equals to 1 or equals to 2. So I'm gonna put it here. So if a player equals to 1, so the yeah, because inside the self.board it can be 1 or 2. Yeah, so I'm gonna use this tag. So if a self.board equal to yeah, equal to 1, yeah, I'm gonna check this self.board, I believe. I thought finished writing the function. No, I forget about how to write it. Let's just check maybe from here. Yeah. Maybe I don't need to do that. Yeah, because this is not the method 2. I think for this method I don't need to do that. I just need to define a row and column and a diagonal, and I don't need to make it separately. Yeah, because sometimes if you wanted to do O(n) squared time complexity, you have to write it more complicated. Sometimes it's difficult to write code more complicated. So the row and column and the diagonal, I don't know which one it is, but it is always dependent on the player. Yeah, so I'm gonna loop through the board. Now I'm gonna check the board. Yeah, I think this code is not so good. Yeah, but let's just finish it. So I'm gonna check the board. So yeah, if the board equal to the value of this player, yeah, so I'm gonna finish this rows and columns. So rows R should plus equal to 1, and columns C would plus equal to 1, and the diagonals so for the diagonals I have to check if R equal to C, so it's gonna be the diagonals 0 would plus equal to 1. So if R plus C plus 1 equal to n, so I'm gonna use the diagonal 1 should plus equal to 1. Yeah, now I can check if now I can check player 1 and player 2. If player 1 wins, I'm gonna return 1, otherwise I'm gonna return 2. So after the for loop, after those 2 for loops, I can write another for loop. So for v in list rows dot values plus list columns dot values, and plus list and diagonals dot values. I'm gonna check this way. If it is equal to n, I'm gonna return the player. Otherwise, I'm gonna return 0. This code maybe yeah, let's just check. This is the row and column, and here we just put the players inside. Yeah, but for each move, we have to run all in square. We have to check the board, loop through the board, and if it is equal to player, we're gonna do something. If it is 0, we will not do anything. So if it is equal to this player, so I don't know if this player is 1 or 2. Yeah, but definitely this player is unique. It can be 1 or can be 2, but I just check this player. I only check this player. Yeah, and I put the rows column and the diagonal. All the values is only for this player. So this means I just need to check if I can meet one of the conditions, rows or columns or the diagonals. If I meet the conditions, I'm gonna return this player. Otherwise, gonna return 0. Yeah, I think my code is a little bit optimized than before. As you can see from here, here is more code. Yeah, but before that, I needed to put the I needed to put the row and column inside the board. So self.board and row and column should equal to this player. Yeah. Now I think it's enough for me to check if it works. Yeah, let me check why. The built-in function is not iterable, so for v inside the built-in function, so for v inside the rows.values, column.values, and the diagonal.values, yeah, I have to check why. Let me just print out rows to check why, or columns, or diagonal. Yeah, it is a dictionary, so for the dictionary I believe I can use a list rows.values and column.values. It is not iterable. The object, it is object rows.values. It should be an array. Because I defined it as a dictionary, default dict int. No, this is a string. Why? Yeah, I forget to use the parentheses. Yeah, now let me check it. Yeah, as you can see, it works. So this is an ON square. For the ON square function, as you can see, yeah, for each of the move, we initialized a column set, a row set, and diagonal set, and we use the 2 for loops. So this is why the time complexity is ON square, and it is not so good. Yeah, let me submit it to SAC if it works. Yeah, as you can see, it works, but it's really slow. It is like 6 seconds. Now we want to try to optimize, if we can optimize it. Now let's try to optimize it. Yeah, by optimizing it, we don't need to use a self.board. And yeah, but we need to use the row set and columns set and the diagonal set. But we need to use the 2 set. So those 1, column 1, and diagonals 1. Yeah, we need to define it globally. So we need to use the self dot. Yeah, and similarly, we need to define a player 2. So it's gonna be those 2, column 2. Yeah, even though we used more variables, but the time complexity gonna be improved. It's gonna be ON, so we're gonna check it later. Yeah. So here gonna be the same. So this n gonna be equal to the self.n, and we don't need to use this self.board. Yeah, because for each of the time we just need to put it inside of the set. We don't need to use this self.board anymore. Otherwise, the time complexity for this move gonna be ON square. Now it's gonna be ON, so we don't need to use the 2 for loops for the board. Yeah. But for the check function, inside of the check function, we're gonna do something. So from here, we're gonna use the rows set and columns set, and we also need to use a diagonal set, and R and C with player. So this is gonna be our function. So basically, we're gonna check this check function. It depended on the player. Yeah. So yeah, so I'm gonna directly call the check function. So self dot is gonna be rows 1, and self dot columns 1, and with self dot diagonals 1. Yeah, because of this designed it like this. And row and column and player, row and column and player. So I'm gonna check if player equal to 1. So I'm gonna call this function. So I'm gonna return this check function. So otherwise, the player must be the player must be equal to 2. So I'm gonna copy it and put it to the rows 2, columns 2, and the diagonals 2. And here gonna be the same. This is just from the parameter from this move method. Yeah. Now I just need to finish this check function. Yeah, I don't need to prepare all those set, because it has already been defined globally from here. Yeah. I don't need to use 2 for loops. Yeah, I don't need to use 2 for loops to put it inside. Yeah, but I need to yeah, so here gonna be this return and return. Yeah, I don't need to use the 2 for loops. But for this check function, I need to put the values inside of the row set, column set, and the diagonal set, and all that is dependent on this R and C. Yeah, so let me first remove these areas, remove the two for loops. Yeah, so how can we do that? So we don't have the self.board. Yeah, but we have so currently if this player equals to 1, so it means I'm gonna put everything inside of this yeah, the set gonna be the rows 1 or columns 1 or diagonals 1. Yeah, I can put it inside directly. Yeah, so I don't need to check that. So for rows with this R, rows R should plus equal to 1, and columns should plus equal to 1. And I need to check if they are equal. So the diagonals 0 should plus equal to 1. So if R plus C plus 1, it means the anti-diagonal equal to n. So the diagonal 1 should plus equal to 1. And after that, I just need to loop through the list. If it is equal to n, I'm going to return this player. Yeah, or I don't need to use the player. I can directly return a 1. Yeah, I think I need to use this player. Yeah, because this is my return. It always depends on this player. So this player is just used for this return. Yeah, which player it is. Yeah, I think this is enough. As you can see, maybe this is much more easier. Yeah, we just need to put it inside and check. Yeah, now let me run it to check. Oh, the check function, what is wrong? Yeah, I need to put it before that. I think currently I cannot access yet because in Python, if it is not self.method, the precision doesn't matter. But if this method without self., yeah, we need to move it up. Yeah, so we can put it here. I need to remove this one. I don't need it. Now let me run it. As you can see, it works. Now I think the code is much more concise because basically we prepared a global variable and rows and column and a diagonal. And this diagonal means just two diagonals, diagonal and anti-diagonal. We put it inside a set. So 0 means diagonal and 1 means anti-diagonal, and similarly for those variables for the player 2. Yeah. So from the beginning, we don't know which player it is, but we have to check. If it is equal to 1, it means it is the player 1. So we're gonna put the players inside, or you can put 1 inside. It doesn't matter. So I'm gonna use a player. Now let me submit it to check. Yeah, as you can see, it works. The speed improved from 6 seconds to 0.1 seconds. I think it improved much for this problem, because before it is O(n) squared for this move method. Now this move becomes O(n). And let's analyze the time complexity, because there will be O(n) squared calls. And for each call, the time complexity is coming from it's coming from here. Yeah, because even though it's like that, the move function is not O(n). It is not O1, it is O(n). Yeah, because no matter what, if we put a value inside, we have to check it, the rows and column and the diagonals separately. We have to check that. Yeah, but for this, actually this is even so for the row start values, so this is like O(n) plus O(n) and plus O2. So this is O(n). So this is why the time complexity is O(n). Yeah, before it is O(n) squared. Now it is O(n) for the move method. Thank you for watching. See you next time.